Hello everyone, welcome to this video. In this video, we shall be looking at sum up to n terms of a GP. So we know the standard form of a finite GP. It is with the first term a and r as the common ratio. The GP is ar square up to ar raised to power n minus 1. So in total we have n terms. We wanted to add all of them. You know, their addition is called geometric series, right? We have already studied this thing. Now what we need to do, we need to calculate what is this value. So we are here using this formula of sum, right? This is given by Sn. Now how do we calculate this Sn? Let's have a look. Now this value of Sn depends upon the value of n. You know, r is the common ratio, so it could have the value 1, it could be less than 1, it could be greater than 1. So in all the three cases, we have different formulas for Sn. Let's have a look at those formulas. When r is equal to 1, what is your GP? Your GP would become a. Then the next term would also be a, because a into 1 would be a into 1 square would also be a into 1 cube would also be a into 1 raised to power n minus 1 would also be a. So that in this case your Sn would be a plus a plus a. How many times? N times. So it would just be equal to n into a, right? This is very simple. Next, when when the value of this common ratio r is less than 1, if that is so, then we have the formula of Sn as a into 1 minus r raised to power n divided by 1 minus r, correct? So this is the formula when the value of r is less than 1. We have to subtract from 1 because in this case 1 is greater than r, right? If r is greater than 1, then we will subtract 1 from this r raised to power n or 1 from this r. So you see the terms here, 1 minus r raised to power n and 1 minus r in case when r is greater, 1 is greater, that means r is smaller, and we have r raised to power n minus 1 and r minus 1 in the case when this r is greater than 1, right? So these are the three cases and three formulas in order to calculate the sum. So let's have a look at a question relating to this concept of calculating the sum up to n terms of a GP. So the question here is, we need to find the sum of first n terms, right? And the sum of the first 5 terms of the geometric series 1 plus 2 by 3 plus 4 by 9 plus so on. So this geometric series is given to us in the form of writing addition in between the terms, right? So we first of all calculate the sum of first 5 terms and then we'll be calculating the sum up to n terms of this geometric series. So here a is given to be 1, clearly it is 1, right? What would be the common ratio? Common ratio is obtained when you divide the second term by the first term. So you divide 2 by 3 with 1, which is 2 by 3. Now you can notice here that 2 by 3, which is r, which is less than 1, hence we will calculate the sum using the formula a, 1 minus r raised to power n divided by 1 minus r. Right, here n is equal to 5 because we are to calculate the sum of first 5 terms. So according to formula, it would be 1, the value of a is 1, right? 1 as such, minus the value of r is 2 by 3 raised to power 5 divided by 1 minus 2 by 3. So when you solve this, it would be 1 by 3, so that when you simplify this, 3 would come in the numerator, this one, and you are left with 1 minus 2 raised to power 5 is 32, 3 raised to power 5 is 243, you may check. So when you subtract them, you would have 1 divided by 243, and the final answer of S5 in this case, because n is 5, so we have the value of S5 is equal to 211 divided by 81. What about Sn? Sn would be the value of a, which is 1 minus the value of r is 2 by 3 raised to power n divided by 1 minus 2 by 3. So when you simplify this, the value of Sn would come out to be 3 times 1 minus 2 by 3 raised to power n, right? So basically we just have substituted n is equal to 5 here in order to simplify and obtain the value of the first 5 terms of this geometric series. So I hope you understood this concept of geometric calculating the sum of n terms of a geometric progression or geometric series. Well, that is it for this video. Thank you for watching.